Welcome to this video lesson. This video lesson is part 1 of algebraic word problems. Before teaching algebraic methods, I often start students off with this question. Just give it to them and ask them to solve it using any methods that they see fit. And it can be solved using many different ways. Pictorial methods, it could be used, solved by algebraic methods, or even trial and error. So what I want you folks to do is actually look at the question, try to solve it, use any method that you want, and then we'll go over problem solving skills that you require with algebra, and then use those steps to solve it using an algebraic method. When solving a problem, if you want to solve it using a logical procedure, you want to first decide on the unknown quantity and allocate it a variable. We often use variable x, but you can use any other variable. We then decide on which operations are going to be used, translate the problem into an equation, so these two are kind of interconnected, and then we solve the equation by isolating the variable. So whatever we're looking for, let's say it's x, we're going to rearrange the formula so that we have x, or the variable, isolated. And once we find our solution, we then check to see our solution if it satisfies the original problem or not. And finally, we write the answer in a sentence form. So let's use the strategies in this example over here, and then we're going to go back and do the original question. Okay, so let's read the question first. It says, when a number is tripled and subtracted from 7, the result is negative 11, and we're trying to find the number. So some of the keywords here are when a number is tripled and subtracted from 7, the result is negative 11. So first of all, our unknown value is a number that we're looking for. So we will write that let x represent the unknown value. We then have to use the wording of the question to come up with an equation. And the wording of the question usually hints at what operations are used inside the equation. So in this one we got when the number is tripled, meaning that the number is multiplied by 3, so 3 times x, and subtracted from 7. So if it had said that it's by 7, then you had to subtract 7. So you would have to write 3x minus 7 if the keyword of by was used. But since the keyword is subtracted from 7, that means it's 7 minus 3x. So 3x is being subtracted from the value of 7. So this is the keyword from. So the equation becomes 7 minus 3x. The result is negative 11. Once we have our equation, we can see that we have one unknown and we have one equation. So we can go ahead and solve for that. And this is how we can do that. First of all, we're trying to isolate the negative 3x term. So to do that, we need to get rid of this 7 over here. We do that by subtracting 7 from both sides. So I will write that in blue. So minus 7, minus 7. That will get rid of this 2. And I will end up getting negative 3x is equal to negative 11 minus 7, which means negative 18. I then have to isolate my variable x over here, so I only have one term. So I can divide both sides by the negative 3 to have x isolated on the left side. So I will do that. So negative 3 on this side and negative 3 on this side. and I will get x, because these two cancel out, is equal to negative 18 divided by negative 3, which is equal to positive 6. Now, does the solution satisfy the original equation? Let's test that. So if x is 6, I will have 7 minus 3 times 6, and that's my left-hand side, which is equal to 7 minus 18, and 7 minus 18 will actually give me negative 11. So this is my left-hand side, and this is my right-hand side of the original equation that I created. So this is my right-hand side, this is my left-hand side, and they are equal when I use the value of 6 as my x. So now that I have checked that my solution actually satisfies the original problem, then I can go back and write my final answer in a sentence form. So I can write that the unknown value is 6. Make sure when you're writing your final sentence, you don't write that the x value is 6, because the original question doesn't ask you what x is. You use the variable x to put this into an equation and solve it algebraically. So to answer the actual question, you can't say that x is 6. You have to say that the unknown value, or the number, is another way you can say it. The number that we're looking for is actually 6. So let's now go back to the original question that we had over here. And let's read the question and make sure that we understand everything. So it says, there's 28 more pages in Harry Potter Chamber of Secrets, which is book 2 of the series, compared to Harry Potter's Philosopher's Stone, which is book 1. The question then says that there's 66 more pages in Harry Potter Prisoner of Azkaban, which is book 3, as compared to Harry Potter The Chamber of Secrets. So if the total number of pages in the first 3 books in the series is 791, find the number of pages in each book. So unlike the previous question that we did, this question actually has 3 unknown variables. One is number of pages in book 1, one is number of pages in book 2, and one is number of pages in book 3. However, we can actually make this into one unknown variable and link the number of pages between book 1, 2, and 3. So let's do that now. We are going to let x be the number of pages in book 1. Then we know that book 2 here has 28 more pages than book 1. So we can say that let x plus 28 be the number of pages in book 2. And we can let x, and the third book actually has 66 more pages than book 2, and book 2 has x plus 28 pages, so I can write that x plus 28 plus 66 be the number of pages in book 3. Now note here, I could have done this differently. I could have said that the number of pages in book 2 be x. So actually I'll write that in red so you can see that. I could have said let x be number of pages in book 2, x minus 28 be the number of pages in book 1, and x plus 66 be number of pages in book 3. And that should yield the exact same answer as what I will get using this set of value, because it still means the same thing, because we're saying book 2 has x number of pages, book 1 has, or book 2 it says that has 28 more pages than book 1, meaning that book 1 will have 28 less pages than book 2. And the last one says there's 66 more pages in book 3 than book 2, so I can write it as this. So let's solve the question using both methods and make sure that we get the same answer. The next big set of information that's given to us is that the total number of pages in the 3 books is equal to 791. So I can write that in an equation, because I know that number of pages in book 1, which is x, plus number of pages in book 2, which is x plus 28, plus number of pages in book 3, which is x plus 28 plus 66 is equal to 791. That's the total number of pages. So now to solve this equation over here, I'm going to look for like terms. So I have x, x, x here, which make up 3 x's. And I will simplify the left side of the equation by adding 28, 28, and 66. And when I add them together, I should get 122 here. So that will equal to 791. I will then subtract 122 from both sides so that I can cancel out the 122 term over here. And then I will get 3x is equal to 669. And finally, to get x on its own, I will divide both sides by 3. That will cancel out the 3 term, and I'm left with x is equal to 223. So once I have this, this means that book 1 will have 223 pages. Book 2 will have 223 plus 28, which is 251 pages. And that book 3 has 223 plus 28 plus 66, which is 317 pages. To check my solution, I can add up the 3 books, or the number of pages in the 3 books. So 223 plus 251 plus 317, and that should give me a total number of 791. And they do add up, so my solution is correct, so that I can give myself kind of a check mark there. And to write my therefore statement, I already have all these written out here, so I can therefore say the number of pages in each book are shown to the left. Now, this is all you have to show for work when you're using an algebraic method. I just do want to solve this using another method just so that we can check to see if we get the same answer, because we're using the same logic. We're still saying that one of the books has 28 less pages than book 2, and that book 3 has 66 more pages than book 2, and that should yield the same answer. So let's try that out now. So now this one says that if I add the number of pages from book 1 plus book 2 plus book 3, I should get 791. So let's simplify the left side. So x plus x plus x gives me 3x, and negative 28 plus 66, the same as 66 minus 28, which is plus 38, is equal to 791. I can now subtract 38 from both sides, and that will cancel out this 38 term on this side, and I will get 3x is equal to 753. And then when I divide this by 3 and this by 3 to cancel out the 3, I will get x is equal to 251. So that means book 2 now has 251 pages. So already comparing my answer from this method and this method, I get the exact same value. So that's good. But let's also try to see if it works with the other number of pages. So book 1 will then have 251 minus 28 pages, which will equal to 223. Book 2 has 251 pages as shown above. So this is pages. And book 3 will have x plus 66 too. So 251 plus 66, which should give me 317 pages. So I don't have to check my answer again because I'm getting the exact same values as I did with my original solution. So just make sure if you did use this method and not this method to write a therefore statement at the end and just to check your answers. But in this case, the reason I did use this method is just to show you that there's not one way to do this questions. There are actually many different ways of doing it. You could also assign x to book number 3 and solve your solution using that method. So if you want extra practice with this, you can actually try that out and make sure that you're still getting the same page numbers for the 3 books. But just to summarize in terms of going through the steps, what we are doing is we're kind of figuring out what is our unknown here. So that is the number of pages in one of the books. And then we're linking the number of pages in the 3 different books. So in the first method that we used, we said x be number of pages in book 1. There's 28 more pages in book 2, so it should have x plus 28 pages, and book 3 has x plus 28 plus 66 because it has 66 more pages than book 2, which has x plus 28. And then we use the other set of information which was given to us, which said the total number of pages of book 1, 2, and 3 is 791. And then we just use some algebra and some rearranging techniques to actually isolate our variable x and to find number of pages of each book. Let's use some other examples to get you a little bit more comfortable with these type of procedures and algebraic procedures. So the first example that we have here says, what number must be added to both the numerator and the denominator of fraction 1 over 3 to get 7 over 8? So first of all, what we're looking for is the unknown number. So let x be the number. Then we have to use the wording of the question to come up with the operators for our equation, and it says what number should be added to both the numerator, so that means my fraction here is 1 over 3, and what number should be added to both the numerator, plus x, and the denominator, so that I can get a fraction of 7 over 8. Now, let me show you a common mistakes that many students make when they're reading this question. So many students say that, okay, what number adds up to both the numerator and the denominator? So they add plus x over x is equal to 7 over 8. But these two expressions, or these two equations are actually quite different. This one, in this one I have 1 divided by 3 plus x over 3 plus x. In this one I have 1 over 3 plus x over x. So if I were to expand this one, I'm just going to write this in another way. It will be 1 over 3 plus x over 3 plus x. Because if you pay attention, here I have 3 plus x, which is the common denominator, and if I have common denominators, I would add the numerator. So common denominator is 3 plus x, and the numerator is 1 plus x. So these two are equivalent. On the right side, however, my common denominator between these two is actually 3x. So if I get a common denominator, I would get 3x, and I would have to multiply the numerator here by x to get, well, denominator needs to be multiplied by x to get 3x here, so this should also be multiplied by x. So 1 times x gives me x, plus 3x, denominator is multiplied by 3, so that numerator also has to be multiplied by 3, so the left side becomes 3x. So I get x plus 3x over 3x, which actually simplifies to 4x over 3x. So these two are in no way equivalent. So in reading the question, you got to be very careful and try to read it very carefully. So this one says what number must be added to both numerator. So here I'm adding a number to the numerator and the denominator right here to give me 7 over 8. So I'm going to kind of cross this portion out just so that you folks know that this is a common mistake that students often make. Now, we have our equation, which is the one right over here, and we need to solve for x value. I have two x values, so I actually have to use some rearranging techniques to get to my final solution. What I will do here is I want to get rid of the denominators first. So I will multiply both sides by 3 plus x in brackets times 3 plus x. And this will get rid of this 3 plus x in the denominator on this side, and I will end up getting 1 plus x is equal to 7 over 8, and I will get 3 plus x on this side over here. I will then want to get rid of the denominator on the right side, which is 8, so I will multiply this side by 8 and this side by 8, meaning that I will get rid of these. And when I multiply, I do have to be careful and put this in brackets, because when I'm multiplying by 8, I'm multiplying the 8 and I have to distribute it to both the 1 and the x here. So I have to distribute it to the binomial here. So I will get 8 times 1 plus x is equal to 7, 3 plus x. So another main common mistake that students often make is when they multiply both sides by the 8 and even the 3 plus x, they don't put it inside brackets. So if you don't leave these in brackets, you will only end up multiplying the 8 and the 7 by the first term, and you won't get the final answer, which is actually correct, because you're missing out on the fact that when you multiply both sides by, or multiplying a binomial by a constant, you have to distribute the constant inside the binomial. So in the next step, I'm going to distribute the 8 to the binomial. I get 8 times 1. So we'll just draw the arrows here. So 8 times 1 is 8. 8 times x is 8x. And that is equal to 7 times 3, which is 21, plus 7 times x, which is 7x. I will then want to bring all my unknowns in one side, so the terms that have the x on one side, I want to bring them to the left side, and bring everything that is a constant value on the right side. So I will do this in I will write both steps in one line. So I will want to get rid of 7x on this side, so I will subtract both sides by 7x. And I will want to get rid of the 8 on the left side, so I will subtract this side and this side by 8. So that will get rid of the 8 on this side, the 7x on this side, and I will end up getting 8x, I'll write it out, minus 7x is equal to 21 minus 8. 8x and 7x are like terms, so 8x minus 7x gives me x, and 21 minus 8 gives me a value of 13. So to check to see if my solution works or not, I will do a little check here. I will grab my original equation, which was 1 plus x, 3 plus x is my left hand side, and my x value is now 13, so 1 plus 13, 3 plus 13. 1 plus 13 on the numerator gives me 14. 3 plus 13 on the denominator gives me 16. And if I simplify this by dividing the numerator and the denominator by 2, I get 7 over 8, which is equal to my right hand side, meaning that my solution is correct. And to write my final therefore statement, I can write therefore the number is 13. Okay, the next question that we're doing is actually an age problem. Let's read the question first. It says, Sarah's age is 1/3 of her father's age. In 13 years' time, her age will be half of her father's age. How old is Sarah now? So what we're looking for, first of all, is Sarah's age. So we can let x be Sarah's current age. Now, in terms of wording, this question is a little confusing, so it's not a bad idea to draw a little table and write current and future and Sarah and father. And using this table, it will help us a little bit with kind of organizing and coming up with an equation to use to solve our problem here. So first of all, Sarah's age currently is x. And if currently Sarah's age is 1/3 of her father's age, that means her father's age is 3 times as much as her age. So just putting some random numbers in, if father was 3, then Sarah has to be 1. If father was 6, Sarah has to be 2, because she's 1/3 of fathers. So going in the reverse order, you can see that fathers are actually 3 times older than Sarah. So now in 13 years time, so that's in future, her age will be half of her father's age. So we know that in 13 years Sarah should be x plus 13 because it's 13 years later, and her father should be 3x plus 13 because it's 13 years later. And now I have a lot of information, but I can't really solve for Sarah's age yet. So I have to look at all the information that's given to me. There's one other piece of information, and that says that in 13 years time her age will be half of her father's age. So in 13 years Sarah's age is x plus 13. If her age is half of her father's, that means her father would be twice as her age in 13 years. So I can write another set of information here, which comes from this part of the sentence here, and that is that her father would be 2 times her age at that time, which is x plus 13. So now I have one set of information here, one set of information here, one set of information here, but 2 set of information here, and this is very valuable because I can actually set this and this to be equal, and using that I should be able to solve for my x value, which is actually Sarah's current age. So let's try that out. So we're saying that father's age in 3 years for sure has to be 3x plus 13. Because her father is currently 3 times older, and in 13 years he will be 3x plus 13. And in future we know that her father's age is 2 times as much as Sarah's future age, which is x plus 13. So 2 times x plus 13 should be equivalent to 3x plus 13. So now, let's solve this and see what we get. We get 3x plus 13 on the left side, but I want to distribute the constant into my binomial here. So 2 times x gives me 2x, and 2 times 13 gives me 26. So then I will want to bring all my variables to one side of the equation. So let's subtract 2x from both sides, so that I can cancel out these terms. And I get 3x minus 2x is 1x, plus 13 is equal to 26. And to isolate x, I have to remove the 13 from the left side. So I will do that by subtracting 13 from both sides. And I get x is equal to 13. So now let's see if this actually all makes sense. So I want to plug in the values into my original set of data and see if everything works out. So now I'm saying that x is 13. So when Sarah was 13, or when Sarah is 13 right now, her father's age is 3 times 13, so that's 39. And in 13 years, Sarah's future age will be 13 plus 13, which is equivalent to 26. And her dad's age is 39 plus 13, which is 52. Now, the final set of information that's given to us is that her father will be twice as old as Sarah in 13 years. So is her father currently twice the age, or in the future, will her father be twice as aged as Sarah? So Sarah in 13 years is 26. Twice as that is equivalent to 52, and therefore this statement holds true, and therefore our solution is correct. And I can finally write that therefore Sarah's current age is 13. Okay, here's the first practice question. Why don't you folks pause the video, try out the question on your own, and then once you're finished, you can play back the video again and watch the solution and actually check your answers. Okay, so this question says, when 3 times a certain number is subtracted from 15, the result is -6. Find a number. So we're going to let x be the number. We will then write this in terms of an equation. So it says when 3 times a certain number, so 3x, is subtracted from 15, not by 15, but from 15, the result is -6. So once I have this, I can start rearranging. So I have -3x and 15 as my terms in left side of the equation. I just want the -3x term to be alone on one side, so I will subtract the 15 from both sides. And these will cancel out, and I will be left with -3x is equal to -6 minus 15, which is -21. I will then divide both sides by -3, and I will get x is equal to 7. To check my answer, I have 15 minus 3 times 7, which is my left-hand side, which is equal to 15 minus 21, which is equal to -6, which is equal to my right-hand side. And therefore, my solution is correct because this is my right-hand side, this is my left-hand side, and I can write that the number is 7. Here are practice number 2 and 3. So why don't you folks pause the video, try out the questions on your own, and once you're finished, play back the video and check your solutions. So the first question says 5 times a certain number minus 5 is equal to 7 more than 3 times the number. What is the number? So what we're looking for is the number. So let x be the number. We then know that 5 times this mysterious number minus 5 is equal to 7 more than 3 times the number. So that means 3 times the number and 7 more of that. So then once I have this, I can just solve. So I want all the variables on the left hand side, so minus 3x on both sides, and I want all the numbers or the constants on the right hand side, so I'm going to add 5 to both sides as well. So the -3x will cancel out this term, so on the right side all I have is 7 plus 5, which is equal to 12, and on the left hand side the -5 and the 5 will cancel out, and I will have 5x minus 3x, which is 2x. My variable isn't isolated yet. It's being multiplied by 2, so I have to divide by 2 to get rid of the 2. And I will end up getting x is equal to 12 divided by 2, which is equal to 6. To check to see if my solution works or not, I know that my left-hand side is equal to 5 times my number, which is 6, minus 5, and that is equal to 30 minus 5, which is equal to 25. And my right-hand side is 3 times 6 plus 7, and that is equal to 18 plus 7, which is equal to 25, and left-hand side is equal to right-hand side, and therefore my solution is correct, which allows me to write a final therefore statement saying that the missing number, or just the number, is 6. For the third example, it says, I think of a number. If I divide the sum of 6 and a number by 3, the result is 4 more than 1/4 of the number. Calculate the number. So let x be the number. So then it says, if I divide the sum of 6 and a number by 3, so that means if I divide the sum of the number and 6 by 3, the result is 4 more than 1/4 of the number. So 1/4 of the number is 1 over 4x plus 4. Now I have my equation, and I have to start rearranging to isolate for x. But the equation kind of looks messy, so what I want to do first on the right hand side is to get a common denominator and simplify it a little bit. So I'll keep the left side as the same, so x plus 6 over 3 is equal to, on the right hand side I have, let's break it down first, so x times 1 on the numerator here is just equal to x over 4 plus 4. So still keep the left hand side the same, but for the right hand side, this 4 is same as 4 over 1, so I can get a common denominator between 4 and 1, which is 4. So 4 needs to be multiplied by 1 to get 4, so x times 1 will give me x, and 1 needs to be multiplied by 4 to give me 4, so 4 times 4 will give me plus 16. So once I have it in this form, it's a little bit easier to deal with. So I can multiply both sides by 4 to get rid of this 4 over here. These 4's cancel out. And I can multiply by 3 both sides to get rid of this 3. And once I do that, on the left hand side I'm just left with 4 multiplied by x plus 6 is equal to, and on the right hand side the 4's have cancelled out, and I'm left with 3 times x plus 16. Once I have this, I can multiply, or I can distribute my constants. So 4 times x is 4x. 4 times 6 is 24. 3 times x is 3x. 3 times 16 is positive 48. So now I will subtract 3x from both sides. So I can cancel out the 3x on the right hand side. And I will subtract 24 from both sides. So I can cancel out the 24 here. When I do that, I get 4x minus 3x on the left hand side, which gives me x. And I will get 48 minus 24 on the right hand side, which gives me 24. Let's check to see if my answer works or not. So my left hand side of the equation is x, which is 24 now, plus 6 over 3. That is equal to 30 over 3, which is equal to 10. And my right hand side is equal to 1 over 4 times 24 plus 4. 24 times 1 divided by 4 is 24 divided by 4, which is 6, plus 4 is equal to 10. So my left hand side is equal to right hand side, therefore my solution is correct, and therefore the number is 24. Why don't you folks read this question, pause it, try to solve it, and then once you're done, come back and check your solution. Okay, this question says, what number must be subtracted from both the numerator and the denominator of the fraction 3 over 4 to get fraction 1 over 3? So let's x be the number. Alright, so what number must be added to both numerator and denominator of 3 over 4, so plus x to get fraction of 1 over 3. So what we will do for this one is we want to get rid of all our denominators first. So times 4 plus x. Make sure you put it in brackets so that you know you got to keep it in brackets later. And then that way you will get rid of it on the left hand side, and you will end up with 3 plus x is equal to 1 over 3 times 4 plus x. And then I want to get rid of the denominator on the right hand side, so I multiply both sides by 3. But when I multiply by 3 on the left hand side, I have a binomial here, so I will keep that in brackets so that I don't forget that I will have to distribute the 3 into the binomial. That cancels out the 3 on the right hand side, and I'm left with 3. 3 plus x is equal to 1. 4 plus x. So then on the left hand side here, distributing the 3 will get me 3 times 3, which is 9. 3 times x, which is 3x. And on the right hand side, 1 being distributed, 1 times 4 is 4, and 1 times x is x. Once I have this, I have to solve for x, so I will subtract x from both sides to cancel out the x on the right hand side, and I will subtract 9 from both sides as well to get rid of the 9 on the left hand side. Once I do that, I will get On the left hand side, 3x minus x gives me 2x, so 3 apples minus 1 apple gives me 2 apples. And on the right hand side, I have 4 minus 9, which is negative 5. So now to solve for x, the left hand side only has one term, so I can just divide by 2 to get rid of the 2. And I will end up getting x is equal to negative 5 over 2. So let's check the solution and see if it works out. I will get 3 plus negative 5 over 2 over 4 plus 5 over 2, or negative 5 over 2. And this is my left hand side. And this means I have 3 minus 5 over 2 on the numerator and 4 minus 5 over 2 on the denominator. Get a common denominator of 2 will give me 6 over 2 for 3, because 6 divided by 2 is 3, minus 5 over 2. And here I will get 8 over 2, which is 8 divided by 2 is 4, minus 5 over 2. Six over 2 minus 5 over 2 is 1 over 2. And 8 over 2 minus 5 over 2 is 3 over 2. So this is same as 1 over 2 divided by 3 over 2, which is same as 1 over 2. Change the division to a multiplication and get the reciprocal of your fraction on the right hand side, and then I will have the 2's canceling out and I'm left with 1 over 3, which is also equal to right hand side, which means that my answer is actually correct. So finally, my therefore statement should be that the number is negative 5 over 2. I can change this to negative 5 over 2 for my solution. Alright, our last practice question is an age question. Why don't you folks pause the video, try the question on your own, and then come back and check your solution. Alright, the question asks, when Maria was born, her mother was 24 years old. At present, Maria's age is 20% of her mother's age. How old is Maria now? So let's let x be current age of Maria. Again, it'll be useful to make a table of this time past and current, Maria, and mother. So when Maria started, we're gonna assume that she had an age of 0, and her mother was 24. Now, right now is x years later, so Maria is at age x, and she's 20% of her mother's age. So her mother's age should be 24 plus x, because it has been x years since. But we have to put that last sentence into an equation, and that's really the challenging part over here. So the last sentence over here says, at present, Maria's age is 20% of her mother's age. So that means 20% is same as 20 over 100 because it's 20% and percent refers to over 100. And if we simplify that, that is 1 over 5. I can divide both the numerator and the denominator by 20, and I will get 1 over 5 as my fraction. This means if her mother right now is 5, she would be 1, which is 1/5 of 5. If she was 10, she would be 2. If she was 15, she would be 3. And so on. We could continue this for a while. But to come up with an equation, we can do one of the following, or to solve this problem, we can do one of the following. One is that we know that her mother is 5 times her age currently, or we can also write that as that she is 1/5 of her mother's age. So I can get two pieces of information from this. I can either say that currently Maria is 1/5 of her mother's age, which is 24 plus x, or I can say that her mother is 5 times her age, which is x. So basically, I can either set these two equal to each other or these two equal to each other and see what I get. I will do both so that you folks can see that you can set up the question in different ways and still get the same answer, and it shouldn't really make a difference. And also I want you folks to see that sometimes it's more efficient to use one method over the other so that your setup will just be easier to solve algebraically. So I will go with the left hand side first. So I'm going to set Maria's age at present is x, and it's also equal to 1/5 of her mother's age, which is 24 plus x. To solve this, I am going to multiply both sides by 5 so that I can get rid of the denominator on the right hand side. So then I will get 5 times x on the left hand side is equal to 1 times 24 plus x on the right hand side. The 1 has to be distributed, so I get 5x is equal to 1 times 24 is 24, and 1 times x is just x. Again, if you multiply 1 by any polynomial inside a bracket, you can just get rid of the brackets because 1 times any number is itself. I will then subtract x from both sides so that I will remove the variable on the right hand side and only have variables on the left hand side. So then I will get 4x, because 5x minus x is 4x, and on the right hand side all I'm left with is 24. I will then want to isolate for x. I have only one term on this side, so I want to remove the 4 by dividing both sides by 4. These two cancel out, and I'm left with x is equal to 24 divided by 4, which is equal to 6. Now, let's check to see if this works. So I said that x, so my left hand side is x, which is equal to 6, and my right hand side is equal to 1/5 of 24 plus x, which is 6, which is 1/5 of, so bed mass, we do brackets first, so 24 plus 6 is 30, and then I will get a 30 over 1. 30 times 1 is 30 over 5, and 30 divided by 5 is 6, so my left hand side is equal to right hand side. So I can check this, and it is absolutely correct. And that means that when Maria is 6 years old, her mother is 24 plus 6, which is 30 and 6 and 30 times 1/5, or 1/5 of 30 is 6, which is Maria's age. So it all works out. Now let's use the other method, which is setting these two to be the same, and see if we still get the same answer. So I'm going to call this method 1, and I'm going to call this method 2. So for method 2, I have to set up 24 plus x is equal to 5x. And what I want to do is, actually, if you look at this right away, is that this and this are exactly the same. So by setting this equation up as my first step, I've already skipped 2 steps over here, and that's just working really efficiently. Let's do it anyways. I want to try to get rid of the x over here on the left hand side, so I will subtract x from both sides. That will get rid of my x on that side, and I will be left with 24 is equal to 5x minus x. So 5 apples minus 1 apple gives me 4 apples. Then I will divide both sides by 4. The 4's cancel, and I'm left with 24 over 4, which is 6, is equal to x. For good form, I will write x is equal to 6. My isolated variable is on left hand side, and what it equals to is on the right hand side. I don't have to check the solution again because I've already checked it here and I am getting the same x values. But I can write my final statement here, which says, therefore, Maria's present age is 6 years old. So for these types of questions, you want to read the information first, set up a table, make sure all the information in the questions are used in your table, and then try to use the most efficient way of solving the problem. So once again, in this one, we had 2 methods to go by. One was to set x equal to 1/5 of her mother's age, or to set her mother's age equal to 5 times Maria's age. And both ways were correct methodologies to actually solve the problem, but by going and using this method, we saved up a little bit of time and we used a more efficient way of getting to our final solution.